Let's take a look at some example graphs where I just uploaded some data to AI and see what happened. Um, let's remember, just because AI proposes a particular analysis method or graph, that doesn't mean it's the actual best thing to do. And sometimes it's actually a bad thing to do. So there's some common graph types that experts actually discourage, but they're still common. So pie charts are a big one. Box plots or box and whisker plots have perceptual difficulties. They seem to decrease the importance of the tails, even though they have just as much data as the box. Dynamite plots, also called plunger plots, is a bar chart with a little fuse-looking thing at the top to indicate some uncertainty. Um, Plots that seem to be three-dimensional, even when the data isn't actually three-dimensional, that can be really confusing. Violin plots seem to be a modern kind of histogram, but they have their own problems. Even aside from these types of charts, the AI might fail to make good suggestions that we humans using our critical thinking skills would probably catch, or at least hopefully. So I pasted some made-up data into ChatGPT, like that's the actual brand name ChatGPT. Please make a bar graph. And I gave some code, so that's good, right? That's nice and reproducible. It's interesting here, it converted parts per million to parts per billion by multiplying by 1,000, so it's doing a good job there. Created a bar chart using these plot commands. So it did basically what we asked. This bar seems a lot taller because it was originally in parts per million. Um, so we should ask, other than that tall bar, what do we notice and what do we wonder about what's going on here? So take a sec to think about that. Well, we could have asked it, are there better ways to present this data? Like we can't see what's going on with chemical A and chemical C here. Would there be other things that maybe I should have told it that are relevant that weren't in the data I uploaded? I think here it's essential to provide some context for each chemical, like what's the recommended maximum or safe amount? From that, we could compute the current amount divided by the recommended max, and then say things like, this chemical is at 100%, 70% of its recommended max value. That would be bad. Or this other chemical is only at 20% of its recommended max. Um, then they could all be on roughly the same Y scale of like percent of recommended max. If we had given it real chemical names, maybe the AI would know the recommended max, but it might also get that wrong. The recommended max might be different in different countries, even or for different people. Um, so I gave the same prompt without the recommended max part to Google's Gemini. So here's the same prompt. Here's a screenshot of what it gave. What do you notice about it? I notice it has a show code button here, so that's good. We can go look at the code it used. I looked at the code. It was okay in my professional judgment. I noticed it put the chemicals in a different order than I gave it and in non-alphabetical order as well. The code said it sorted by value for better visualization as per guidelines, but it wasn't the guidelines I gave it, so I don't know what guidelines it was thinking of there. I also noticed the Y scale has these weird unequally spaced tick marks. And the Y scale is going from like 10 to the 1, which is 10, to 10 to the 2, which is 100. So it goes up by a factor of 10, up by another factor of 10, up by another factor of 10. That's not how y-axes usually work. Usually we add the same amount each time, not multiply. Um, it's okay. It's called a logarithmic scale, and it's acceptable in some cases, especially among people trained in STEM already, but it can be confusing if you're trying to communicate with the general public. So we got to watch out for that. General lesson being, if it's suggesting a graph or analysis you don't understand, don't just go with it. Either learn enough to understand it and verify it and explain it maybe to other people, or ask it if there's a simpler but still valid way. Also, think about what if the data in your spreadsheet changes? Will you have to re-upload it to AI? Or can you learn what you saw in AI and redo that in the spreadsheet? So then if the data in the spreadsheet changes, the graph will change. Some AI tools might have a way where you can like save the analysis methods and just upload the new data set and maybe it'll refresh. I think Julius has something like that, but I haven't really played around with it. Let's also look at the idea of using image generation AI to generate plots. Like here, I was just using the usual chat interface, but if you say, well, I want an image, right? A plot is an image. So if I use the same tool that would generate an image of like blue whale at a hummingbird feeder or something fun, if I just pasted this in to the image generating part and it gave me these and asked what I thought. So what do you think of this image that it gave me? And it also gave me this other one. It asked me which one I like more. So, what can we say about these? I noticed it's showing the lake as polluted. It's got a dead fish, it's got a tire, it's got factories with smokestacks or something. But there's no guarantee the lake is actually more polluted than any other lake. Maybe it's very clean. Maybe these chemical amounts are just fine. I don't know. It's showing different amounts of chemicals or solutions containing the chemicals that aren't proportional to the amounts I gave it. Like this beaker or whatever looks like a lot more than three times this one, considering how in three dimensions it would be rounder around the back. And this 10 looks like a lot less than this 5 somehow. So that's concerning. It also showed the 5 parts per billion as safe for chemical green, colored it green, for chemical A, colored it green, but it has no idea what the allowable level is. It doesn't even know what the chemical is. So how did it decide that was safe? I don't know. So again, using our human critical thinking, and it's fun to make fun of AI here, but really this is a good exercise in just if someone shows you an image or a chart or an infographic, question some of the decisions that went into it.